I wanted to do a video now all about ways in which the space elevator could actually be good for the environment, or the ways in which we could mitigate the environmental impacts of using a space elevator in terms of the sort of fuel that it would be using. So the design I've come up with is a design supported by jet engines and rocket engines in order to relieve compressive strain from the structure. However, running jet engines and rocket engines comes with of course a large degree of potential environmental impact in terms of CO2 emissions and so on. The jet engines will of course be releasing CO2 into various stages of the atmosphere, into of course the troposphere and the stratosphere. So we don't know, like for instance, if you're going to release CO2 into the troposphere, that will, via convection currents, eventually circulate back towards ground level and be absorbed by plants in most cases. However, up in the stratosphere has its own convection currents, so it gets sort of trapped there and lingers around and never really sort of gets back to ground level. So whether or not we offset the carbon emissions from the space elevator, there will still be a lot of carbon floating around in the stratosphere, which might not actually be such a bad thing. Hear me out on this. It might actually cause a net zero effect in a sense with the emissions released in the troposphere, which go back to ground level. That does create a greenhouse effect. However, releasing carbon dioxide into the upper stages or into the stratosphere, into the upper stages of the atmosphere, might actually create a global cooling effect. It might create a sort of a blanket of CO2 up there, which causes the Earth to get slightly cooler, in fact, and actually reflects more radiation back into space than the infrared radiation reflected from the surface or re-emitted from the surface does in the troposphere, creating this greenhouse effect that we're all aware of. So it might create some net benefit actually. So like the way in which we need to understand the environmental impacts of it is to engage in sort of microclimate modelling with the assumption of a space elevator and the assumption that it will be releasing emissions of some description into the stratosphere. So there would also be a degree to which we need to consult with climate scientists and get their opinions on what exactly sort of greenhouse effect it might cause in terms of its direct emissions, whether or not that is indeed balanced out by global cooling. Then there is the issue of the rocket engines up in the mesosphere, which I would like to run on hydrogen. However, it is very difficult to contain and pump liquid hydrogen, since it needs to be kept at something like minus 247 degrees or something like this, some very, very low cryogenic temperature, and it might be a very difficult challenge indeed to conduct all that liquid hydrogen up the various stages of the space elevator into the mesosphere. So it might necessitate us actually burning something like methane in the rocket engines. But then again, I think if we're going to be pumping liquid oxygen up there, which you need for a rocket engine, I think it might be just as expedient really, and not perhaps so much of a technical hurdle to overcome to actually pump liquid hydrogen up there. Although in its own right, that will indeed be a significant engineering challenge of the project, and will not be something that we could necessarily take lightly. However, if we do indeed use liquid hydrogen and liquid oxygen to power the rocket engines in the mesosphere, then we will necessarily be releasing water vapor into the mesosphere, which is a greenhouse gas. Indeed it is. It's actually a more potent greenhouse gas by several factors than CO2. However, again, we might run into this situation whereby we are in effect reflecting more sunlight than we are trapping, if you see what I mean. We'd be reflecting more light back into space than is caused by the greenhouse effect, or the two effects will balance out. That might be the case. However, what the space elevator allows us to do is to engage in far larger projects in space and build far larger infrastructure in space. So, one prospect that we have at the moment is, for example, engaging in geoengineering to some extent and engineering our way around these problems such as drought and climate change. Like we can't make it rain necessarily. We have cloud seeding that we do with silver oxide delivered from aircraft. However, that is not always possible to create rain clouds that way. You need to create areas of high pressure and low pressure to induce rain. A lot of evaporation from the seas with a lot of heat doesn't necessarily mean that you're going to get a large number of rain clouds come over a given area. What you need to do really is get that evaporation on the one hand, and then for areas of low pressure to emerge, whereby you have less heat. So what you need to do is you need to get the evaporation in the first instance, get all that water vapor up into the atmosphere. Then you need to cool it down basically such that it condenses into big rain clouds and condenses ultimately into rain and falls on the land. So one way of doing this is to use infrastructure. I'm thinking of like something like huge, very large shields in space to basically block out sunlight reaching the planet's surface, to create shade on land or over land, which would be possible in the future, hopefully with space elevator technology, and to, in essence, selectively lower the temperatures of the land at different points, which would also protect our crops and things like this, which have suffered greatly in this immense heat, and yields of various things are significantly down, and we could do this to protect the land, and also to induce areas of low pressure through cooling, since we know via, of course, the ideal gas law that if you increase the temperature of a gas, you get an attendant increase in the pressure of a gas, which really is sort of obvious. You know, you excite all the atoms in the gas and start jiggling around. You know, you get more pressure, right? Obviously, so just more energy in the system, more light radiation entering the atmosphere. You get high pressure, and that's what we're basically living through at the moment with this drought. We've got this huge system of high pressure going on where it's constant sunlight, constant jiggling around of the atoms, and no cloud formation, no condensation of water vapor in the atmosphere, and hence no rain, if you see what I mean. So by blocking out sunlight, we usually lower the temperature, the energy dissipates, you get cloud formation, you get the water vapor in the atmosphere condensing into clouds and ultimately into rain. So that could be one level on which geoengineering may well be a necessary step forward for our civilization, and it would be facilitated by a space elevator. It would be a high priority thing to accomplish if we're to tackle, frankly, climate change. It is one intriguing and viable, I think, prospect that we could be engaging in, other than attempts to suck CO2 out of the atmosphere, since CO2, like, it doesn't we can't necessarily take it all out of the atmosphere. Nature itself isn't going to take up all that CO2. The sort of the factory, the plants we built to sequester CO2 in rocks and things like this, they're not necessarily going to be able to take it all out of the atmosphere, if you see what I mean. So we need to sort of live with the fact that we've actually passed climate tipping points, and now we need to be looking more at strategies for mitigation of the effects of climate change, and thinking, I think, more about geoengineering prospects, and space would provide a rather great deal of instrumentality in tackling that problem, I suspect. And a space elevator would make things like these big solar shields over continents like Europe and North America viable. So yeah, indeed, we could be doing these sorts of things in the future with space elevator technology. Hence, space elevator technology could be instrumental to a very great extent in tackling climate change. And that's roughly what I wanted to say in this video. And yeah, let's just I want you to have to think about that for the time being. And yeah, thank you for watching.